So same data from yesterday. I want you guys to flip back to yesterday's and write down the equation for the line of best fit and the slope. Line of best fit and the slope. Oh, that is so loud. All right. While you guys are copying down that information from yesterday, here's the program that I used to come up with that pretty scatter plot. I want you guys to know how to do it on your calculators because on the exam you don't get computers. You do get your calculators. So here's the scatter plot of the data yesterday. And this program allows me to get a whole bunch of interesting information. So here's our equation, if you didn't have that written down already. There were 30 people, so n is 30. The standard error of B, SEB, is this 1.332. So I took this whole box right here, and that's what I had up on the screen. Let me pull that back up again. Come on. Oh, I love it when it works. There we go. So I pulled that whole little box over here. That's where I got that from. And that's why it was not printed on yours. Yep. So this all just came from Statlet. That's the website that I used. Line of best fit, writing that in context. Instead of y hat, that would be score hat, because that's our y variable, our response variable, equals 85.95 minus 1.517 times the rho, because rho is our explanatory variable, our independent variable. And then the slope, which we found with our calculators yesterday, that's also right here, negative 1.517. What did we say that meant in context? Yeah, what did the slope mean in context? There's only one word that I wanted to hear in there that I didn't hear. Predicted. The predicted score goes down by 1.517 points for every row, for every additional row moved back. So every one more row. If I were to take another random assignment of 30 students, do you think that the slope of the least squares regression line would be the same? Do you think we would come up with exactly negative 1.517? If I did another random assignment. Exactly the same? Not exactly the same. Possibly close. What about if I did it 3 times? Do you think any of those 3 would have the exact same slope? No. Every random assignment is going to give different results with a new least squares regression line and a different slope. Today, our focus is going to be on taking the information from yesterday and constructing a confidence interval. Yesterday we mentioned what the parameter was. Does anybody remember? That our null hypothesis would be that the slope of the true population least squares regression line was 0. But what did we call the true slope of the population least squares regression line? What symbol did we have for that? Beta. Yes. And what did beta represent? I kind of just said it. My parameter would be the true slope of the population least squares regression line for row X and score Y. In different contexts, my X and my Y are going to be different, but I want to make sure when I'm defining my parameter, because we have to do that again. You don't have to define parameters for chi-squared, but for everything else we have to define our parameters. The true slope of the population least squares regression line, that part's going to stay exactly the same for all of the confidence intervals or significance tests that you do for slope. But your context here is going to change for X and for Y. What do you think our statistic would be? That's exactly right. The slope of our least squares regression line, so negative 1.517. How many conditions do we normally have to check? 3. There are 5. We have an acronym to remember all 5 of them. Liner. Which kind of makes sense because we're working with lines. The L stands for linear. The scatter plot needs to show a linear relationship, and the residual plot should not have a leftover curved pattern. So I pulled this off of Statlet. So here's the scatter plot that we had. Calculators made the same one, but it didn't have the nice pretty blue dots. And then here's the residual plot. I want you guys to get a quick sketch, it doesn't have to be perfect, over on the right side of your page. And I don't know if you guys remember, but back when we talked about least squares regression lines first semester, and we say it has a linear relationship, really what I'm looking for is it doesn't obviously look like another shape. I don't see a parabola shape. I don't see an exponential shape, that J shape. And I can really see that when I check the dot plot of the residuals. Ty, what's residual again?
Oh, actual minus predicted.
Actual minus predicted, yes. So the plot of the residuals is taking what the predicted score would be and subtracting the actual minus what the least squares regression line is predicting at that point. So basically, how far off? It's the vertical distance away. That's what my residuals are showing here. The residuals need to not have any kind of leftover pattern in them. I should not see a parabola shape in my residuals. I should not see any kind of pattern at all. No Christmas tree patterns, no J-shaped patterns. The residual plot should kind of look like random scatter. We do have to check independence. Most of the time that means checking for what? 10%. In this case, we were saying that we had a class of 30 people and we assigned all 30. So we were not sampling without replacement. So we get away without doing the 10% here. But each observation is independent of the next. Most of the time, you are going to have to check that 10%. If you are sampling without replacement, then you have to check the 10% condition. To check for normality, we have to make sure that the dot plot of the residuals, right here, does not show a strong skew or outliers. I don't see a strong, heavy skew in my residuals. I don't see any outliers that are way far away from the rest of my data. The E in Liner stands for equal standard deviation. The residual plot does not show a clear sideways Christmas tree pattern. We have roughly equal variability at each X value. Kind of the same thing I'm looking for with linear. If I see a leftover pattern here, it doesn't have equal standard deviation. And then we have to check our randomness condition. So same 3 as before, except now we also have to check for linear and equal standard deviation, which we do both of those using the scatter plot and the residual plot. Residual plot for both of them, scatter plot for an approximately linear relationship. Yes, I got to look up again exactly how to do that, but yes, we can do that on there. I haven't done it since first semester, so. So in our 4-step process, the first step for a confidence interval is to do what? Name your parameter. And what else do we need for a confidence interval? Super close, that's for a significance test. Confidence level. We need to define our parameter. We need a confidence level. Step 2, plan, that's where we check our conditions. That's also where we name the test that we're going to be using. We'll name that test here in just a second. And then we're going to use the same general formula that we've always used for a confidence interval. What's the general formula for a confidence interval? Point estimate plus or minus margin of error. Yes. I'm going to hang out here on this page for just a little bit longer until everybody has a chance to get everything down, and then we'll go to the next one and we'll finish out the bottom of this page. Why did we say yesterday that it was random assignment and not random selection? What kind of thing did we say it was yesterday? Was it an observation or experiment? It was an experiment so that we could show causation, but we still checked our randomness box because we had random assignment. That's also why we got away with not having to check our 10%, because again, we weren't sampling. We were doing random assignment. On your page, go ahead and write down the general formula underneath number 4, the point estimate plus or minus margin of error. I'll come right back to the screen. Just give me a moment. All right, so general formula, point estimate plus or minus margin of error. Specific formula, what do you think our point estimate is here? B. Plus or minus, do you think this is a Z star or a T star situation? T star, why? We're gonna perform a t-test, what'd you say? It's not using means, we're actually looking at slopes here. The reason we use T is because we are estimating for 2 different parameters here. We're going to use degrees of freedom n minus 2. We are estimating the slope and the y-intercept. So how many degrees of freedom would we have for this particular situation? 28. Where did we go find SE sub B again? that table. It was the standard error of our slope. Standard error of the slope. It came off that table. It's also printed on your page. That was that 1.33 number. I want you guys to go ahead and find your confidence interval here. Go ahead and continue the do step. We're going to do a 90%. Let's do 90%. Or sorry, 95. 95. I misread my own handwriting. I'm sorry. We'll do a 95% confidence interval.
Good.
All right. I'll go back to that other screen so you can finish getting your scatter plot. All right. There you go for the residual plot. So I want everybody to calculate the confidence interval here. And the standard error of B is right here. We do B, which is the slope. That's this. Plus or minus. And then we have our T star. So this is where we have to look it up on the chart. We're using n minus 2 degrees of freedom. Since there were 30 people in the class, we're going to use degrees of freedom of 28. There it is. And a 95% confidence interval. Standard error of the slope is this right here.
Oh.
Yeah, if you finish up your confidence interval, try your hand at writing the conclusion. We've practiced writing conclusions over and over and over. See how you can do with that. You don't need that bottom plot. Is anybody comfortable sharing their confidence interval? We got negative 4.241 If you took it out further than that, that's okay. To 1.207. Your T star should have been 2.048. And now we need to conclude. How should my conclusion start? We are 95% confident. For row and score, yes. There's only one little thing that I would do, very little. I would add context next to my interval, that negative 4.241 to 1.207 points per row. Remember, those are estimates, or that's the interval for our slope. Slope is rise over run, y over x. Our y is the score, and the x is the row. So when we're talking about slope, the units would be points per row. I'm going to make sure to get your context in there. Using just the confidence interval, if I asked you whether we would reject or fail to reject the null hypothesis, what would you say?
Fail to reject.
Fail to reject. Why? What is it about that confidence interval?
Zero's there.
0 is in the confidence interval. And remember, our null hypothesis was that the slope was 0. There's no relationship here. 0 is contained in the interval, so it's plausible that there is no relationship. We are pretty much ready to talk about our big ideas. If you are still working on getting the notes down from this page, give me a quick hand so that I know whether or not I should scoot on. Okay. Rather than the slopes. The confidence interval part's not too bad. Checking 5 conditions is a little,
Yeah.
yeah. All right, let's go ahead and flip the page over. So 4-step process for confidence intervals. State, plan, do, conclude. In the state step, beta is equal to the true slope of the population least squares regression line for x. Give me context. Tell me what that x is. Tell me what the independent or the explanatory variable is. And y. Include your context. Tell me what y represents. What is that response variable? What is the dependent variable there? Plan, the name of the test. This is a 1-sample t interval for slope. 1-sample t interval for slope. And then we have to check our 5 conditions. We've got liner to help us remember what those 5 components are. L for linear. I for independent, that's where we check 10% if it's necessary. N for normality. How do we check normality on this one? Yeah, no strong skew or outliers in which dot plot? In the residual plot. We want to look at the residual plot for that. Equal standard deviation and randomness. And then, of course, our do step, point estimate plus or minus margin of error. B is our point estimate, so slope of our least squares regression line plus or minus T star. We use degrees of freedom n minus 2. Most of the time it's n minus 1. We do n minus 2 because we're estimating the y-intercept and the slope here. And then the standard error of the slopes, SEB. This will come from some kind of output. I don't know how to find that on your graphing calculators. But most of the time they're going to give you that Minitab output data. And in the past we just ignored some of those other numbers. Now we have a use for them. And then we conclude. Let's walk our way through the check your understanding together. We're going to do a 4-step here. A thrill seeker wanted to try to travel across a large field while being suspended in the air by holding on to balloons. This sounds like a genius plan.
Yeah.
I do believe
see no problem here.
I do believe there is a Darwin Award that's this same idea. In order to determine the number of balloons needed per pound of weight, he did a preliminary study. Okay, so he put some thought into his stupid idea.
Not enough.
He selects a random sample of 20 rocks of various sizes. He weighed each one and also determined how many balloons are needed to lift the rock. Here is output from a least squares regression analysis of the data, and I don't have all of that up on the screen yet. What do we need to pay attention to in the data that they gave us? The shape. Let's check this for our conditions. Do we have an approximately linear shape with our scatter plot? Yes. Checking the residual plot. Is there a leftover pattern? Nope. So we get our linear. What did the I stand for? Independent. And what do we use to check for independence? 10%. How many rocks did he sample? 20 rocks. So there needs to be at least 200 rocks. Fair assumption? There are at least 200 rocks. All right, so that's L, I. What's the N? Normality. What do I look at for normality? Residual plot. I can look at this guy, or this guy's a little bit easier for me to check for strong skews and outliers. Do we have any strong skews or outliers here? Not really. Okay, so L-I-N-E. Equal standard deviation. So now I'm looking at this residual plot right here. Do we have a Christmas tree shape? No. Do we have any kind of leftover shape? Not really. So we have equal standard deviation. So L-I-N and then R. Random. Do we get random? Why? Random sample of 20 rocks of various sizes. All right. So we just checked all of our conditions. Scatter plot shows a fairly linear pattern. Residual plot has no leftover pattern. We have at least 200 rocks. Dot plot of the residuals shows no strong skew or outliers. Equal standard deviation. Residual plot shows similar variability for each x. Remember, standard deviation is talking about variability there. We get our random because a random sample of 20 rocks. I need one other thing in the plan step. What else do we always put in our plan step?
Procedure name.
Procedure name. What is the procedure name here? One sample t interval for slope. Not a t-test. T-interval. Make sure not to put the star in there. T star is a number. T is a distribution. just to do something a little different than normal. Let's do a 90% confidence interval this time. How would we define this parameter? Beta equals
true slope of the population, least squares regression line for rock weight.
Rock weight and
Number of balloons.
number of balloons. Which one's X, which one's Y?
Weight of the rocks is X.
Weight of the rocks is X. Number of balloons would be Y. All right, we've done the first two steps together. I know some people are working on getting it all written down, but I want you guys to finish this out. I'm going to give about 5 minutes for you guys to finish out the rest of this confidence interval, and then we'll check yours against mine. That's okay. That's all right.
round off or do we have to put them in as exact? Exactly as they state them.
I usually put them in as exact, but I might round for my actual interval.
Okay.
So I go exact all the way until the end.
Okay.
And I know some people are still working. For my do step, point estimate plus or minus margin of error. What is the point estimate? Yes, 30.4126. T star, because we have 18 degrees of freedom, should be 1.734. And then the standard error of B. When you look at the Minitab data, it'll say SE above a column. You want the one that's down by the slope, because we want the standard error for the slopes, 2.416. And so you should get a confidence interval of roughly 28.87 to 33.95. How would we conclude something like this? Yep. Thank you. I wrote my number wrong. 26.87. Thank you for catching my mistake. $26.87 to 33.95. What would the conclusion look like? We are 90% confident that the interval 26.87, 33.95. What units should we put with this? Weight per balloon or pounds per balloon? There we go. Captures the true slope of the least square regression line for weight x and number of balloons y.